Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Multi-modeFiber has been the workhorse for fiber optic communication within a data center for years, as well as a choice for Ethernet backbones in office buildings. It has a rich history that goes all the way back to the first optical fiber standards when 100 megabits per second was a huge data rate. Anybody remember those days? This is episode 55, and we continue our conversation with Hao Dong, Market Technology Development Manager for Corning's optical communications business. We get into power consumption considerations, fiber coupling efficiency, and multi-modeFiber standards. Hao Dong is a Market Technology Development Manager for Corning's optical communications business. Within this role, he focuses on technology and market trends to identify, evaluate, and develop leading optical network solutions that form the backbone of today's connected world. Hao has over 18 years of industry experience and has held various positions in engineering, development, and marketing within the fields of optical components, fiber lasers, and optical communications. Hao holds a Bachelor of Science in Physics from Wuhan University and a PhD in Physics from the University of Connecticut. And now join me as I talk with Hao Dong. So they're thinking more about the equipment side. And if they're comfortable with multi-modeFiber, it's just a very nice comfort zone. And so even at 400 gig, if that's available, then yeah, that's what they're going to gravitate toward.
Right. So especially, like we mentioned before, right? For multimode solution, not only we consider it as a lower cost solution, but also there is a great feature of the lower power consumption. And especially nowadays, when those data centers, they start to deploy, machine learning, AI, and those applications, it's very, very power hungry, right? And also for those applications, it might involve a lot of communication functions in there, right? So end of the day, the power is a big concern. Power is the lower power consumption of the VCSEL of the multimode solution. We still think it's very much valuable for those
That's a great point. So the VCSELs are basically lower power than you mentioned the DFB laser. Do you want to talk about that a little bit too?
Yes, yeah. The VCSEL, I think there is physics behind that, why the VCSEL consumes the less power. If you look at the lasing threshold, right, the VCSEL usually comes with a much lower lasing threshold than the DAB laser. So the other thing is, you also mentioned this point before, right? So when it comes to the fiber coupling, the multi-mode solution is much more efficient when it comes to the VCSEL launching light into multi-mode versus the DAB into single mode, and therefore, your coupling efficiency is high from the power standpoint. By adopting the multi-mode, you have the better chance to utilize your power source. So end of the day, the multi-mode, really offering you the power consumption benefit versus single mode. So this is not only true for 100G level, right? For 100G level, for example, I think we used to do some analysis to quantify the power comparison. For a 100G transceiver, typically it's an NRZ base, right? You wouldn't need a CDR, a TI as electronics, and also, of course, plus the optics. So I think, typically speaking, the VCSEL-based multimode will deliver around 40% power savings versus the single-mode transceiver counterpart. When the speed migrates to higher speed, the whole situation is getting a little bit trickier because everything is no longer NRZ based, right? Everything will migrate to PAM4, so that you have to sort of deploy the very power hungry PAM4 DSP,
yeah,
right? And from that perspective, the electronic contribute the percentage of the power contribution from electronics is getting higher. But still, we would say even though the gap, the power gap between single mode and multi-mode is shrinking, but specifically 400G multi-mode still deliver around 20% power savings from the transceiver standpoint versus single mode. So
well, some of the electronics is not necessarily in the optic module. Like with the 400 gig QSFP-DD, both the FEC and the PAM4 modulation, it's in the host, the switch, the Cisco switch, basically.
Oh yeah.
So you get a little bit of relief in the module there. I'm not sure exactly how much, because there definitely is still electronics in the module, more so than in the lower speeds.
Right. If that's the case, the optical will play a more important role, right? From that standpoint, that your VCSEL, power saving feature is more outstanding.
Yeah, definitely. Power is a very big topic these days.
Exactly. Yeah, because especially these days, a lot of the companies, the organizations really concentrate on the sustainability perspective, right? So I think I read an article talking about how power will important how important the power is for the data center operation. So roughly speaking, I think over 40% of the data center monthly spending will be either directly or indirectly related to the power. So eventually, the thing is, since the power is so critical, right? Since the power is so important, it makes sense for data centers to kind of like leverage everything they could to lower the power consumption, including from the transceiver standpoint, right? If you look at the whole situation from that way, I think we would say the multi-modeFiber, the multi-mode solution, it's especially valuable, right? From the economical impact standpoint, even from the PR value standpoint.
Right. If you don't mind, if we could pivot just a little bit, you mentioned organizations. That makes me think of standardization organizations. With multi-modeFiber, for people who have worked with it a bit, they've probably seen standards called OM3, OM4. There's an OM5 there. There used to be OM2, and there was an OM1 also, wasn't there? Can you explain maybe the history of this, where it came from, and what these all mean?
Sure. So, I mean, if you look at the history of the multi-modeFiber, probably we could look at it from a very simple way. Look at the core size, history of the core size for the multi-modeFiber, right? So, if you trace back to the beginning, the very beginning of the multi-modeFiber was designed with a 62.5 micron core.
Okay.
So for those fiber, I think it was categorized as OM1. So of course, it's defined by ISO or IC standards. It's a 62.5. Obviously, it's bigger than the common multi-modeFiber core size, which is 50 micron nowadays, right? So that was designed for matching the LED light source. So of course, that's even though it's a very low cost light source, but the problem is that it's low power and low brightness.
So this is before VCSELs were around and people would be using LEDs?
Yes, this is before, exactly. This is before a VCSEL came around as a workhorse, and OM1 actually it was defined in the mid 80s. So.
Okay. And when did OM2 come around?
OM2, I think it came around in the early 90s, if I remember correctly. So, so OM2, OM3, and OM4, for those fiber, they were defined by ISO, IEC standards. and they all have a 50 micron core design, right? But the problem is that they have a different bandwidth or so-called information carrying capabilities. Okay. OM2 now, OM2 in more or less, in my opinion, is an interim option. So today, it's nearly obsolete, and we typically we don't recommend the OM2 for new installation anymore. So one of the big reasons is, if you look at the, like I said, the bandwidth, right? So for speed of the 10G or greater, OM2 can only support a very short distance. So for that reason, OM3 and OM4, as a laser optimized multimodal fiber, that was considered as a workhorse for the new installation nowadays.
So what did they optimize? So OM2 was for LEDs. That was the fourth part of my conversation with Hao Dong. Next time, we'll get into multi-modeFiber standards. We have a new website. It's optics.podcastpage.io. You can either listen there or use the same podcast platform you've been using all along. Please subscribe. Better yet, leave a review, especially if you've been using Apple Podcast. Remember, we're part of the Cisco Podcast Network, where you can find other great Cisco podcasts too. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 5 of my conversation with Hao Dong. Until next time.